This is my Rubik's Cube solving robot. It's based on an ESP32 microcontroller and it's got 3 servos and a stepper motor. So the sensors at the top work out the colours of the tiles and it creates a 3D version of the cube in software. It solves this 3D version in just a few milliseconds. While it's doing it, it fills out an array with all the actions that it takes. It then runs through this array and physically moves the real cube and thereby solving it. Firstly, I modelled the cube in Tinkercad, then designed the mechanics to do the movement and 3D printed all the parts. Everything screws down onto a plank of wood to make it strong. It also saves in 3D printing. The large stepper motor at the bottom turns the turntable. There are 2 servos for the pushers and 1 to drive the flipper. The sensor PCB has 3 photodiodes that drive 3 transimpedance amplifiers which feed into the A to D inputs of the microcontroller. So there are 5 LEDs per sensor, red, orange, green, blue, yellow, which cover the spectrum. They fire in order and I look at the reflected light that comes back to determine the colour for each tile. So at the moment I'm running the calibration routine. I can use this to automatically set and store the expected values for each tile colour on the EEPROM. In this way, if I buy a new cube with slightly different shades, I can automatically update the robot. So that's it. There's a 12-volt socket on the back. There's a Hall effect sensor there with a magnet glued underneath the turntable so I can initialize the sensor. There's a buck regulator on the board which I generate the 5 volts for the ESP32 and the servo motors. The stepper motor runs on 12 volts to give it the oomph. Yes, I could have used a colour detection chip to do the colours, but it's not so much fun. Where's the fun in that? That's it really, all done. Right, I'm going to run it again.